So equable shapes. So remember, what is an equable shape? So we've defined an equable shape is when the area equals the perimeter. So remember, what we are interested in is to try and find as many equable shapes as we can. So the decision that we've made is to start with rectangles, just because it's reasonably straightforward to find out the area and the perimeter. So we decided to start with, let's try and fix one length of a rectangle. So we decided to fix the length to be 3 centimeters. So we first of all, we worked out, what about if we've got a length of 3 and a width of 1? So the area 3 times 1 is 3. Remember the perimeter. You add these together, then you double it. 3 add 1, double it. Remember, you can use a calculator, okay? So if anything come across is a little tricky, you use a calculator, right? And then we thought 3 by 2, okay? And we did the same. We did 3 by 3, 3 by 4. Notice the nice, neat table. 3 by 5, 3 by 6. Oh, wait a minute. See, look, I was going to carry on, but then I found an equable shape. Look, these two are the same. So what would we then decide? We then decided to look at, so we tried a length of 3. So maybe try a length of 4 and do exactly the same thing. 4 by 1, 4 by 2, working out the area, working out the perimeter, and putting it in a nice, neat table. 4 by 3. Keep going. See if the areas and the perimeters end up being the same. Oh, there it is. We found an equable. It's equable. And look, there it is, just there. So I'm going to highlight the key ones on my table. Equable. Right, we did 4. So what might be a good idea now? Let's try a length of 5. Now if you try 5, something a little bit odd happens. So I'm going to show you. So we try 5. I do exactly the same, okay? So 5 by 1, 5 by 2, then 3, then 4, then 5. Now oddly, I haven't found an answer. There doesn't seem to be one, does there? Got 5 and 12. Now something weird's going on here. What I'm going to do at the side here is I'm going to write down which is the biggest. See, the perimeter is the biggest there. The perimeter is the biggest there. The perimeter is the biggest there. Which is the biggest here? The biggest here is the area. And the area. What does that tell me? Well, annoyingly, like the two we've just done, when we did 3 and 4, they gave us nice numbers. This one doesn't give us a nice number, but the answer must be in there somewhere. So it must be 5 by, well, there are numbers in between 3 and 4. What numbers are in between 3 and 4? So what we're actually going to do is we're going to expand this bit of the table just here. Right, we're going to expand it. Let me show you what that's going to look like. So here's my table. Now remember, you can use a calculator here, okay? Here you go. Look at the numbers in between. Just here. We wouldn't normally write those down. We didn't need to do that first, but I'm going to do that here. How do I work out this one? It's 5 multiplied by 3.1. So if you wish, get yourself a calculator and just do 5 multiplied 3.1. Get an answer. And we get 15.5. So that one would be 15.5. That's probably not a very good choice of colour for me, is it? So let's just go over that in a slightly darker colour so you can see. There you go. Right, how do we work out the perimeter again? Remember, it's add these two together. So 5 add 3.1. Get the answer. Get the answer. And then double it. How do you double it? You multiply by 2. Equals 16.2. And then go through and work out the others. Now, I've already done this for you. Let's have a look. I'm going to show you. There you go. So I've got those. What would be a good idea? What would be a good idea here is just to maybe do the next couple just to check them yourself. And then you can then see. Okay, just make sure that you know how to work these out. Now I'm going to do the same. Can I find when the area is equal to the perimeter? Well, do this. Write down which number is bigger. Well, the perimeter is bigger. The perimeter's still bigger, still bigger, still bigger, but very close. And then the area's bigger, the area's bigger, the area's bigger. And then the area, and the area, and the area. Now that's really close for my answer. Just here. Right, that's like that. Look at that. 16.5, 16.6. But it's not quite, is it? Now, there's a little challenge for you here. I would accept you to say, oh, well, it's equable at 5 by 3.3. But maybe you could go a little bit further. Maybe you could expand this. Could you expand that even further? So your table would look something like this. So you'd have 5, so start with 5 and 3.3. But your next number might be 5, and then what's a little bit more than 3.3? 3.31. And then 5 and 3.32. And so on, and carry on. Maybe try that. All right, then you might even get closer than what we managed here. But we know that's really, really close. But you can explore that a little bit more. Remember, use your calculator. Right, that's fine. Let's go a little bit more. Let's go a little bit more. So what would I then try after 5? Let's say I managed to get that answer. Okay, I'm going to try 6. Now, I'm not going to show you this one, because that works out quite nicely. Okay, I'll let you do it. 7, on the other hand, not so nice. So if you work it through, something very similar happens. We end up getting, oh, there's no place there the same. But if we write, which is the bigger one? The perimeter. I nearly wrote area then. Perimeter. Perimeter. Area, area. Have a look in there. That means look from 7 by 2.1, 2.2. So I'm just going to show you what the table looks like. Now I've not filled this in. I'm just going to show you, just so you can get started. So I'm going to do something like that. And then try and find it where it's the same. Remember, you might need to zoom in again. What next? Now I think there's plenty there to be getting on with. Right, plenty. Remember, you go back, you can watch some bits again. Nice, neat tables. Alright? And have a little think about what you might do next. Now there's plenty there to be getting on with.